Today, we are mastering the techniques for solving cubic equations. We deal with equations of the form ax cubed plus bx squared plus cx plus d equals 0, where a is not 0. This is a critical skill for your Cambridge IGCSE Additional Mathematics exam. By the end of this lesson, you will be able to systematically break down any cubic expression into its linear factors to find its roots. This topic is essential because it bridges the gap between basic algebra and higher-level functions, often appearing in complex calculus and coordinate geometry problems. To solve cubic equations, we rely on two fundamental theorems. The first is the Factor Theorem. It states that if a polynomial p of x is 0 when x equals k, then x minus k is a linear factor of that polynomial. This allows us to turn a numerical root into an algebraic building block. The second is the remainder theorem. When a polynomial p of x is divided by the linear term ax minus b, the remainder is simply the polynomial evaluated at b over a. If this remainder is 0, then x minus b is a factor. We will use these to break down complex cubic equations into manageable parts. To solve a cubic equation, ax cubed plus bx squared plus cx plus d equals 0, we follow a four-step systematic approach. First, we find a single root using trial and error. We test small integer values like 1, -1, 2, or -2. These are usually factors of the constant term d. Once we find a value k where the polynomial equals 0, we apply the factor theorem to identify x minus k as our first linear factor. Next, we divide the cubic polynomial by this linear factor using algebraic long division. This leaves us with a quadratic quotient. Finally, we solve that quadratic either by factorizing it or by using the quadratic formula. This gives us the remaining two roots. Let's solve the cubic equation x cubed minus 6x squared plus 11x minus 6 equals 0. We start by testing small factors of the constant term, -6. Let's try x equals 1. Substitute 1 into the function. Calculating this gives 1 minus 6 plus 11 minus 6, which equals 0. Because the result is 0, the factor theorem tells us that x minus 1 is a factor. Now, we divide the original cubic by our factor, x minus 1. Dividing the cubic by x minus 1 gives us the quadratic quotient, x squared minus 5x plus 6. Step 3 is to factorize the quadratic quotient. We need two numbers that multiply to 6 and add to -5. Those are -2 and -3. Finally, in step 4, we state all the roots. The fully factorized form of our equation is, therefore, the solutions are x equals 1, x equals 2, or x equals 3. Visualizing cubic functions helps us understand the nature of their roots. A cubic function can have 1, 2, or 3 real roots, depending on how many times the graph crosses or touches the x-axis. Notice the blue curve. It crosses the x-axis at 3 distinct points. This represents a cubic with 3 distinct real roots, like the example we just solved. Now, look at the red curve. It just touches the x-axis at -1 before turning back. This is what we call a repeated root. In this case, x plus 1 squared would be a factor. Finally, the green curve only crosses the x-axis once. This means the function has 1 real root and 2 complex roots. In your IGCSE exam, if your quadratic quotient has a negative discriminant, you found a case like this. The orientation depends on the leading coefficient, a. If a is positive, the graph goes from the bottom left to the top right. If a is negative, it starts top left and ends bottom right. Let's tackle a typical Cambridge-style exam question. Solve the equation 2x cubed minus 3x squared minus 11x plus 6 equals 0. We test factors of the constant 6. Let's try x equals -2. We substitute -2 into the function. 2 times -2 cubed minus 3 times -2 squared minus 11 times -2 plus 6. This simplifies to negative 16 minus 12 plus 22 plus 6, which equals 0. Since the result is 0, the factor theorem tells us x plus 2 is a factor. Next, we divide the cubic by x plus 2 to reduce it to a quadratic. Our quadratic quotient is 2x squared minus 7x plus 3. Step 3. Solve the quadratic. We can factorize this by looking for numbers that multiply to 6 and add to negative 7. The quadratic factorizes into 2x minus 1 multiplied by x minus 3 equals 0. This gives us the roots x equals 1/2 and x equals 3. By combining all steps, we find the three roots for this equation. X equals negative 2, x equals 0.5, and x equals 3. Even top students can lose marks on cubic equations due to simple slips. Here are the three most common mistakes to avoid. The most frequent error is misidentifying the factor. If you find that p of 2 equals 0, the factor is x minus 2, not x plus 2. Always flip the sign of the root when writing the linear factor. Algebraic division is where many marks are dropped. If your remainder is not 0 after dividing by a confirmed factor, you have made a calculation error. Stop and recheck your subtractions immediately. When factorizing quadratics like 2x squared minus 7x plus 3, many students forget the 2 and write x minus 1 times x minus 3. Always ensure your factors multiply back to give the correct leading term of the quadratic. The question often asks to solve, not just factorize. Don't stop at the brackets. Ensure you clearly state x equals ... for every root you found. To secure those top marks in your IGCSE exam, keep these professional tips in mind. When performing trial and error for the first root, only test factors of the constant term d. If the constant is 6, don't waste time testing x equals 4 or x equals 5. Stick to 1, 2, 3, and 6. You can quickly verify your division is correct by using the remainder theorem. If x minus 3 is your factor and your division gives a remainder, you've made a mistake. A 0 remainder is your green light that you're on the right track. In Cambridge papers, if Part A asks you to show that x minus k is a factor, and Part B says, hence, solve the equation, you must use the factor from Part A. Do not start the trial and error process over again. If a question provides a sketch, use it. If the graph crosses the negative x-axis, your roots should reflect that. It's a great way to catch sign errors before you hand in your paper. Now it is your turn to practice. Please pause the video and solve these three questions before continuing to the solutions. For the easy question, factorize and solve x cubed minus 4x squared plus x plus 6 equals 0, given that x plus 1 is a factor. For the medium question, solve x cubed minus 7x minus 6 equals 0. For the hard question, the polynomial f of x equals 2x cubed plus ax squared plus bx plus 3 has a factor of x minus 1 and leaves a remainder of 15 when divided by x plus 1. Find a and b, then solve f of x equals 0. Take your time with these. The hard question requires you to set up simultaneous equations using the factor and remainder theorems. Let us look at the solution for the easy question. The equation is x cubed minus 4x squared plus x plus 6 equals 0, and we are given the factor x plus 1. Since we are given the factor, we divide the cubic by x plus 1 immediately. The division of x cubed minus 4x squared plus x plus 6 by x plus 1 gives the quotient x squared minus 5x plus 6. Now, factorize the quadratic x squared minus 5x plus 6 into x minus 2 times x minus 3. The final solutions are x equals minus 1, x equals 2, and x equals 3. For the medium question, we must find the first root ourselves. The equation is x cubed minus 7x minus 6 equals 0. Testing x equals minus 1 gives minus 1 cubed minus 7 times minus 1 minus 6, which equals minus 1 plus 7 minus 6, which is 0. So x plus 1 is a factor. Dividing the cubic by x plus 1 gives the quadratic x squared minus x minus 6. Factorizing x squared minus x minus 6 gives x minus 3 times x plus 2. The roots are x equals minus 1, x equals 3, and x equals minus 2. Finally, the hard question involving simultaneous equations. The function is f of x equals 2x cubed plus ax squared plus bx plus 3. Using the factor theorem for x minus 1, f of 1 equals 2 plus a plus b plus 3 equals 0, which simplifies to a plus b equals minus 5. Using the remainder theorem for x plus 1, f of minus 1 equals minus 2 plus a minus b plus 3 equals 15, which simplifies to a minus b equals 14. Adding the two equations gives 2a equals 9, so a equals 4.5. Then b equals minus 9.5. Substitute a and b back into f of x and divide by x minus 1 to find the remaining roots, using the quadratic formula. To conclude, let's summarize today's key takeaways. First, always use the factor theorem to find your first integer root. Second, apply algebraic division to reduce the cubic to a quadratic expression. Third, use the remainder theorem when solving for unknown coefficients. Finally, remember that cubic graphs can intersect the x-axis at 1, 2, or 3 points. To summarize today's lesson on cubic equations, remember that if the polynomial evaluated at a value k equals 0, then x minus k is a guaranteed linear factor of the equation. Always follow the workflow. Find the first root by trial, identify the linear factor, perform algebraic division to reduce the degree, and solve the resulting quadratic. A cubic equation can have 1, 2, or 3 real roots. Visually, these are the x-intercepts where the graph crosses or touches the axis. Success in IGCSE Add Maths depends on accuracy. Verify your first root carefully and ensure your division results in a zero remainder before proceeding to the final roots.